Let's see what's going on here. So we've got f is a function, cool. So, and then we've got the second derivative of f is given to us right here. And then they're asking us at what x coordinates are the points of inflection. So as soon as I see that terminology right for a problem like this, the points of inflection is telling me I need to know that definition first and foremost. So points of inflection have to fit two criteria. First, they have to be the places where that second derivative equals zero or that second derivative is undefined. Then the second thing that has to happen is it also needs to change concavity at that point, at that x value. And only when it does both of those things does something get to count as an inflection point. So I go to see what I've been given again, and I say, okay, this is nice because this is giving me my second derivative, and I need to know when that second derivative equals zero. So instead of having to go get the second derivative, they're flat out giving it to me, so I don't have to waste my time with that. And I need to know when does that equal zero. They're also being super awesome because normally you'd have to factor this thing into a bunch of stuff being multiplied before you could find your answers. Because they've factored it for us, we can now just break this up into 3 bite-sized little math problems. So whenever x to the fourth equals 0, that's a possible inflection point. Whenever x minus 2 equals 0, and then whenever x plus 4 equals 0. These are all possible inflection points for us. So solve those math problems real quick. I fourth root both sides of that to cancel out x to the fourth. So that gives me x equals 0, possible inflection point. Add 2, add 2. I get x equals 2, another possible inflection point, and then minus 4, I get x equals negative 4, and those are my 3 possible inflection points. To determine if they are inflection points or not, I have to fulfill the second requirement as well, which is they need to change concavity. And this is where you would do what's called the second derivative test when you were learning it in class. This is really just our number line game. So we're going to draw out a number line. We're going to mark our inflection points on that. So then I've got, moving left to right, I've got one at negative 4 as a possible inflection point. I've got a possible inflection point at 0. And then I've got a possible inflection point sitting out here at 2. This is a second derivative test, so I need some test values. I'm going to need to choose a test value from each of the regions that I just created. So something to the left of negative 4, I'm going to go with negative 5. That's a test value. Something between negative 4 and 0, I'm always going to go with negative 1. It should make the math easier. Something between 0 and 2, I would always go with 1 if it's an option. And then something to the right of 2, we're going to go with 3. So this is a second derivative test, so we need to test all of these values in the second derivative. So we need to go find what is f double prime of negative 5 equal. We need to know what is f double prime of negative 1 equal. We need to know f double prime of 1, and then we need to know f double prime of 3. Remember that when we're doing this, we don't need to know the full number. We just really need to know, is this thing going to be positive or negative? So as I come through and take and start plugging these in, I start with the second derivative at negative 5. So I'm taking my original equation, and everywhere I see an x inside it, I'm going to be plugging in negative 5. So this would be negative 5 to the fourth, negative 5 minus 2, and then negative 5 plus 4. And so when you do this, remember, you don't always need to know negative 5 to the fourth. What you need to know is any number taken to a fourth power, to an even power, that's going to be a positive. Remember, this is just about the sign of it at the end. So then negative 5 minus 2, that's going to give me a negative number, and negative 5 plus 4, that's going to give me a negative number. So multiplying these two things, a negative and a negative gives me a positive, and a positive times a positive gives me a positive. So I don't care about the number, I just care that I now know it's positive, and therefore concave up like a cup in that section. And I draw out the concavity as I'm doing it. It just really makes it a lot easier to visualize and come back and get it. So f double prime of -1, plug in -1 into this same equation, that second derivative equation they gave us. Everywhere I see an x. And I work the same type of logic. So the front here is always going to be positive no matter what. A -1 minus a -2 is going to give us a negative, and then a -1 plus a 4 is going to end up giving us a positive. So in this situation, when I come to multiply them together, a positive and a negative is going to end up giving me a negative out of this whole thing. So again, don't care about the number, just care that it's negative in between those two. And so it's concave down like a frown. Keep running through this, and this is why you got to have a method for being quick on these, is you don't have a lot of extra time to be doing 5 to the 4th and things like that. So you really need to be able to have some logic like this that you can lean on to make these problems quick and easy. So coming back through this, 1 to the 4th, that is still positive like always. 1 minus 2, that's going to give me a negative. And then 1 plus 4 is going to give me a positive. And so here I see, multiplying these signs together, I end up with a positive times a negative, which is going to equal a negative. So between 0 and 2, this is negative and concave down like a frown. And now we just have that one last number to calculate out. So f double prime of our last, not 3, f double prime of our last test number. And that's why I label them test and critical or point or inflection point, depending upon the problem. Just because it's so easy, especially when you're moving quick, to grab the wrong number off a number line. And nothing will frustrate you more than grabbing the wrong thing and getting it wrong because of something silly like that. So coming back through here, we get 3 to the 4th. That's again going to be positive. 3 minus 2, also going to be positive. 3 plus 4, also going to be positive. A whole bunch of things positive being multiplied together leaves us with a positive. So our second derivative at 3 is positive and concave up. I come back through and I need to review what I have now, because remember, what we're trying to do is make sure they fulfill the second part of this, which is they also need to be a place where this changes concavity. So it changes concavity. It goes from positive to negative at -4, so that's going to be an inflection point for sure. At 0 here, it goes from negative to negative, so that's actually not changing concavity, so that one's going to get thrown out. And then as I go from 1 over to 3, as I go through the second inflection point, I change from negative to positive, so x equals 2 is also an inflection point. So out of our 3 possible inflection points, we only ended up with 2 real answers because at x equals 0, it didn't change concavity. So we're looking when x equals 2 and when x equals -4. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.